We're also going to look at a minimizing problem. This is number 13 on the same page, 335. This is about a water supply manager for a Midwest city that needs to supply the city with at least 10 million gallons of drinkable water per day. The supply may be drawn from the local reservoir or from a pipeline to an adjacent town. The local reservoir has a maximum daily yield of 5 million gallons of water, and the pipeline has a maximum daily yield of 10 million gallons. By contract, the pipeline is required to supply a minimum of 6 million gallons per day. If the cost per 1 million gallons of reservoir water is $300, and that for pipeline water is $500, how much water should the manager get from each source to minimize daily water costs for the city? And now I have summarized the information as you see there. And again, we first want to look at, are we maximizing or are we minimizing? Well, we are minimizing. We're minimizing the cost of the water. Okay, so we first want to identify our x and our y, our variables. We can let x be the amount of water that we get from the reservoir. Y be the amount of water we get from the pipeline. So next, we need the equation for the cost of the water. And it costs $300 per 1 million gallons from the reservoir. And then it costs $500 for each 1 million gallons from the pipeline. And we're trying to minimize this. In order to minimize it, we need our system of linear inequalities. In reading the information, the supply needs to be at least 10 million gallons of water. So the water we get from the reservoir and the pipeline needs to be at least $10 million. Well, so when we add the amount from the reservoir plus the amount from the pipeline, it needs to be at least, it needs to be greater than or equal to 10 million gallons of water. And then reading on that the reservoir has a maximum yield of 5 million gallons of water. So the most we can use is 5 million gallons. So that's got to be less than or equal to 5. And then the pipeline has a maximum yield of 10 million gallons of water. So it cannot be greater than 10. It's less than or equal to 10. But it does go on to say that by contract, the pipeline must provide a minimum of 6 million gallons of water. So minimum is at least. So that is y must be greater than or equal to 6, but at the same time less than or equal to 10. And also an additional piece of information that we always want to consider is that you can never have a negative amount of water. So we can also put an additional restriction on x, saying that x must be greater than or equal to 0. And so that is our system of linear inequalities. X plus y is greater than or equal to 10. X has got to be less than 5, but greater than or equal to 0. And y must be less than or equal to 10 and greater than or equal to 6. And this is how we would set up this problem. And again, in 6.2, we're just setting up the problem. In 6.3, we're going to see how we're going to use this information to find how much water that we'll need to minimize the cost.